Our Chapter 2, Section 3 video will be in two parts. Today, Part A, we're going to focus on the product rule. A product rule is if you have two differentiable functions times or multiplied together, such as f of x times g of x. To find the derivative of this, you take the first function, just like it's written, times by the derivative of the second function, plus the second function, times by the derivative of the first function. Or another way you can say that is the derivative of f times g is the first times the derivative of the second plus the second times the derivative of the first. So let's try a few examples using the product rule. Example 1 will let our first function be the 2x plus the 3, and our second function be the 4x squared plus the 2x minus the 3. So using the product rule, I copy down the first function, take the derivative of the second function, plus the second function, just like it is, just copy it down, times by the derivative of the first function. And then we're going to simplify using our algebra rules, using the distributive property for this first set of products, and our distributive property for the second. Combining like terms, we find the derivative of y is equal to 24x squared plus 32x. Alright, repeating the process for example 2, our first term is x squared plus 1, so we copy that down, times by the derivative of x cubed plus 1, which is 3x squared, times the second term, which is x cubed plus 1, times by the derivative of the first term, which is 2x. And then using algebra, simplify down our problem. We end up with f prime of x is equal to 5x to the fourth plus 3x squared plus 2x. Okay, for example 3, let's try a slightly more complex problem. For the first term, 2x cosine of x, we will need to do our product rule. And then we have 2 times sine of x, so that's just a coefficient, so do not use a product rule for the second term. So I take my first times the derivative of the second, plus the second times the derivative of the first, minus my constant times the derivative of sine of x. Simplifying down, and combining any like terms if we have them, we end up with our derivative of h prime of x is equal to negative 2x sine of x. Example 4, first thing I want to do is I'm going to rewrite that square root of x as x to the 1/2 power, and then I'll use the product rule. So my first term times the derivative of my second term plus my second term times by the derivative of the first. Simplify using algebraic laws to get our final answer of our derivative. The second objective for this section is to be able to find the derivative of all trigonometric functions. We already know the derivative of sine is cosine, the derivative of cosine is negative sine, but in this section we're going to learn the other 4 derivatives. The derivative with respect to x of tangent of x is equal to secant squared x, whereas the derivative with respect to x of cotangent x is negative cosecant squared. Derivative of secant is secant x times tangent x. Derivative of negative cosecant is negative cosecant x times cotangent x. Notice that if the trig function starts with a c, when we take the derivative of it, we're going to always have a negative. So this helps you remember which trig functions derivatives are negative and which are not. In this example, we're going to find the derivative of f of x, which is secant of x times tangent of x. So we're going to use the product rule. So we're going to take the first times the derivative of the second plus the second term times the derivative of the first. For f prime of x is equal to secant of x tangent squared of x plus secant cubed of x. When trying to find the derivative of complex expressions, it's often beneficial to simplify before you start taking the derivative. So let's look at this example. It's pretty complex with lots of trig functions. But before I take my derivative, I'm going to use our knowledge that we have from our pre-chapter on trigonometry to simplify each expression before taking the derivative. And I can rewrite y is equal to cosine of x plus 3 sine of x plus 4x cosecant of x, cosine of x. And so now I can easily differentiate this. Instead of having to do the product rule twice, I only have to do it once in the last term. If you would like to test and see if this method was a lot easier to simplify first than last, feel free to rework this problem using the product rule from the very beginning, and you'll find that it's much easier this way. Our next two derivative identities you need to know is that the natural log of x is equal to 1 over x. Now notice that there's a requirement that x has to be greater than 0. If you remember for your logarithm rules, the inside function of a logarithm must be positive in order to find the logarithm. Our second rule is the log base a of x is equal to 1 divided by the natural log of a times x. So let's let y equal 3x squared plus 2 times by the natural log of x. So I'm going to use the product rule here to simplify to find the derivative of this function. So when I differentiate, I take my first term and I times it by the derivative of the second term, which will be 1 over x, plus my second term times by the derivative of the first term, which would be 6x. Combining like terms and simplifying, I get 3x squared plus 2 divided by x plus 6x times the natural log of x. Usually with logarithms, we write them after our polynomial term. Let's try another logarithm example. This time I'm going to let y equal 20x squared times log base 3 of x minus 5 times the natural log of x. So this time I have to do the product rule twice. So when I differentiate this, I'm going to let my first term be 20x squared. So I'm going to write my first term times by the derivative of the second term, which is 1 over the natural log of 3 times x, plus my second term times by the derivative of my first term, which is 40x, minus, now this one I have a constant, times the derivative of the natural log of x, which is just 1 over x. Using my rules of algebra, I'll simplify this down to 20x squared over the natural log of 3 times x plus 40x times log base 3 of x minus 5 over x. And I can do one more thing. On the first fraction, I can simplify the x out. And this would be our derivative of y. Our last rules I'm going to learn today is the derivative of e to the x is e to the x, and the derivative of a to the x, a number raised to a power, is the natural log of a times a to the x. So I'm going to use the product rule here. So I take my first times the derivative of the second, plus my second term times the derivative of the first, and then distributive property or the full method, using algebra to combine any and all like terms. We end up with our final answer. The derivative of f is equal to x squared e to the x plus 8x e to the x plus 4e to the x minus 6x squared minus 18x plus 22. This time g of x is equal to 3x cubed times e to the x plus 3 to the x times cosine of x plus sine of x times by 3x squared plus 2x minus 1. So I'm going to have to do the product rule 3 times in this problem. So in the first one, we're going to take the first times the derivative of the second, plus the second times the derivative of the first. And then now for 3x times cosine of x, we're going to do a product rule yet again. First times the derivative of the second, plus the second times the derivative of the first. And then finally, in our last term in the original problem, I'm going to do the product rule again. First times the derivative of the second, plus the second term times the derivative of the first. Whew, that was a long one. Now using algebraic rules to simplify if it is possible. Notice again we write our number, our trig function, then our logarithm when we have them all together in one term. And unfortunately, no other terms will combine, so this will be my derivative. So we have a lot of derivative rules that we've learned so far. So here on this screen is all the derivative rules that we've learned up to now. Please, please, I encourage you, make flashcards, start practicing these, start memorizing them. You need to know all of these. They'll start showing up very, very quickly.